Hey guys, we're going to take notes on sickle cell anemia and talk about it a little bit. So go and open your notebooks to a blank page, title it Sickle Cell Anemia Notes, and let's get started. All right, so what is sickle cell anemia? Well, you already should know a little bit about it if you've been doing all your work this unit, but let's take a look at it. So we can see that you got normal red blood cells on the left, and on the right you got sickle cells. So we can see what problems these things cause. Their misshaping causes them to bunch up in capillaries. So they're not going to clot like big blood vessels, like, think of a heart attack. They're not going to clot those, but they will clot capillaries, which can kind of give you the same problems as like type 2 diabetes, but these could be even more life-threatening. So sensitive organs for these little clots and capillaries right here, that'd be like your kidneys, your liver, your eyeballs, your skin, stuff like that. So those are pretty vital organs, and they're not going to be getting the oxygen supply they need. So that's why this disease is dangerous, and that's what it is, just misshapen red blood cells, because you're not making the protein right that keeps the blood cells nice and round. All right, let's go back and let's write some notes. So what is this? Sickle cell anemia is simply a misshapen red blood cell. And why is it so dangerous? It's dangerous because it causes microscopic blood clots in sensitive organs. Yeah, y'all thought my writing was bad on the board, but this iPad is horrible. Okay, so what's a cure? Well, it's only caused by one gene, so stem cell therapy is kind of emerging. Obviously, in poorer countries, that's not going to be an option. So really the best way to do this is give you blood transfusion. So if you're not getting enough oxygen to your body because you got too many sickle cells, they also don't transport oxygen that well. That's another thing I didn't mention. But simply a blood transfusion from a healthy person can help you get through the next, couple weeks or month. So the best treatment is going to be blood transfusions. All right. And then also stem cell therapy. That's emerging, and like I said, because it's only caused by one gene, it's actually it's going to be one of the easier diseases to cure, but takes a lot of money. So that's not helpful to poorer countries. And how common is this? Well, in the U.S., we'll talk about how common it is in the world, but in the U.S., there are about 100,000 cases of this, which makes it pretty rare. Okay, so we have about 100,000 total cases of this sickle cell anemia. All right, pause the video if you need to and write that down. I'm going to move on. Here's a live image of what they look like. So this is actually what they look like. We have healthy on the left and someone with sickle cell anemia. Notice they also don't have that many red blood cells because as far as I know, these red blood cells don't live very long. So they typically have just less red blood cells overall than a healthy person because they don't have that 28-day lifespan like the healthy person over here would. All right, let's talk about something else called sickle cell trait. So this is actually far more common in the world and far more common in the United States. Now, a lot of people get these questions wrong on the test because they mix up sickle cell anemia and sickle cell trait. Okay, let's go back and look at that. There's two things you can call it. Sickle cell anemia is the same as sickle cell disease, sometimes it's called, but sickle cell trait will always be called sickle cell trait. Okay, so what is sickle cell trait? Well, it's far more common because you only have to have one mutated allele to get sickle cell trait. Okay, so this is almost like you're a carrier because you have one normal allele and you have one sickle cell allele. These are basically genes you get from biological mom, biological dad. So sickle cell trait, you can see that the red blood cell appears normal. Okay, so this is actually, most people with sickle cell trait live a fairly normal life and never have a problem. But you are a carrier, which means your kid can get it. But that's not the worst part of it. So let's go talk about sickle cell trait. So how do you get this? Well, let's do some genetics. Okay, we'll be talking about genetics later on this unit. So let's go ahead and get comfortable with the Punnett square. All right, so let's say both your parents were carriers for sickle cell. So that's actually a realistic scenario in the United States. There are 200,000 new kids born with sickle cell trait every year in the United States. So this is a likely scenario. We got both parents who are carriers of the trait, and both parents are probably normally healthy. So we got one kid that inherits no alleles for sickle cell trait. Two of the kids will be two out of 4 kids will be carriers, and then 1 out of 4 kids, so 25% chance of inheriting the trait. So this is a common scenario. This is why there are 100,000 cases, because if we get 2 people that have a kid who both are carriers for it, then they'll have a 1 in 4 chance of having a kid with sickle cell trait, or sickle cell disease, which is that nasty disease. So that's the genetics of it. That Punnett square shouldn't freak you out. We'll do Punnett squares with blood typing later, and then you'll have time to freak out then. All right, so let's take some notes on sickle cell trait, and we'll talk about why this could potentially be dangerous. All right, so sickle cell trait, you are a carrier for sickle cell anemia. For sickle cell anemia. All right, your cells are usually normal. Okay, so the red blood cells are usually normal. Once again, I apologize for the writing. However, this is where the kicker comes in. Your cells, red blood cells, can sickle or change shape under high heat. So that's where it becomes dangerous, because someone with sickle cell trait, once again, 200,000 new kids born in the United States every year with this, problem. Everyone really call it a disease. But their cells have half of the misshapen proteins that they need, half of the mutated proteins, you could say as well. So what's going on here? Well, under high heat, their cells could flip and become sickle. So under high heat, they could go from this to this almost instantaneously. So what's high heat? Well, high heat could be basically anything over like 105 degrees. And you're thinking, well, how does the body get to 105 degrees? And it actually get there very easily if you're exercising outside in high humidity in the middle of summer. This can happen. So this has caused it can cause instant death in athletes during summer sports. So what happens there, a person with sickle cell trait, they get overheated in the summer. It's usually at the start of the summer, they're out of shape. So someone out of shape in a situation where it's high stress, high heat, those blood cells will actually change shape, and that person, the coach just thinks they're overheating, so they have them sit down, but that's not what's happening. All their blood cells have changed shape, and they can't get that oxygen to the brain they need, so it basically causes them, it's called instant death. Obviously, it's not instantaneously, but that's what it's called. So it's a very dangerous thing. The good news is, and this isn't good news for y'all, but it's good news for the future. Since 2006, all new babies in the United States have been tested for this. So since 2006, all new babies are tested for sickle cell trait because it is potentially life-threatening. Since 2006, every new child born has been tested with it. So I don't think that includes y'all guys. I think y'all were born around like 2002 or something like that. So there's a good chance you haven't been tested for this. But once again, this is only deadly if you're extremely out of shape and you get into a high heat, high intensity situation really quickly. So generally, this disease right here doesn't cause a problem as long as you stay in shape before you start some sort of high intensity, high heat sport. All right, let's talk about the distribution of it. So you can see that the majority of people in the world who have this live somewhat along the equator. Obviously, the darker red colors means a higher percent of the population has sickle cell anemia and sickle cell trait. So there's a reason for that. Even though this disease is deadly, there's a reason why it's such a common thing. And that's going to be the question I'm going to leave y'all with. Why is sickle cell disease or sickle cell anemia so common around the equator, even though it's a life-threatening disease? Once again, we're not talking about sickle cell trait that might, has a low probability of killing you. We're talking about sickle cell anemia that will lead to a shorter lifespan. So why is sickle cell anemia or sickle cell disease so common around the equator, even though it is extremely dangerous? So that's a question you need to answer to finish up your notes. Have a good day, guys.